A very good morning, students. Today in climatology, we'll be reading about air masses and fronts. For a clear understanding of the various types of atmospheric disturbances, the study of air masses provides an essential background. Air masses that move along as part of the large-scale motion systems of the general circulation are largely responsible for bringing about changes in day-to-day weather, particularly so in the middle latitudes. Therefore, air masses also play a dominant role in producing different types of climates. After going through this module, you'll be able to understand air masses, the definition, the characteristics, their types, and fronts and their types. Meaning of an air mass. An air mass may be defined as a large body of air whose physical properties, especially temperature, moisture content, and lapse rate, are more or less uniform horizontally for thousands of kilometers. According to A. N. Stroller and A. H. Stroller, a body of air in which the upward gradients of temperature and moisture are fairly uniform over a large area is known as an air mass. An air mass may be so extensive that it may cover a large portion of a continent, and it may be so thick in the vertical dimension that it may vertically extend through the troposphere. It may be pointed out that since a single air mass is so large that it may cover hundreds of thousands to millions of square kilometers of the Earth's surface, and hence horizontal homogeneity of an air mass in terms of its physical properties may not be practically possible, because the nature and degree of uniformity of the air mass properties are determined by the properties of the source area and the direction of its movement, changes introduced in the air mass during its journey away from the source area, and the age of the air mass. The vertical distribution of temperature in an air mass and moisture content of the air are two basic properties of an air mass which control the weather conditions of an area affected by that air mass. An air mass is designated as cold air mass when its temperature is lower than the underlying surface, while an air mass is termed warm air mass when its temperature is higher than the underlying surface. The boundary between two different air masses is called a front. The physical properties of an air mass are determined on the basis of the characteristic features of the surface through which it travels. An air mass also affects and modifies the temperature and moisture conditions of the areas visited by it, and in turn it is also modified by the local conditions of the visited areas. Source regions of an air mass. The extensive areas over which air masses originate or form are called the source regions, whose nature and properties largely determine the temperature and the moisture characteristics of the air masses. An air mass originates when atmospheric conditions remain stable and uniform over an extensive area for fairly long periods, so that the air lying over that area attains the temperature and the moisture characteristics of the ground surface. Once formed, an air mass is seldom stationary over the source region. Rather, it moves to the other areas. An ideal source region for an air mass must possess the following essential conditions. Firstly, there must be extensive and homogeneous Earth's surface so that it may possess uniform temperature and moisture conditions. The source region should be either land surface or the ocean surface, because irregular topography and surface comprised of both land and water cannot have uniform temperature and moisture conditions. There should not be convergence of air, rather there should be divergence of airflow, so that the air may stay over the region for longer period of time, and thus the air may attain the physical properties of the region. It is thus apparent that anticyclonic areas characterized by high barometric pressure and low pressure gradients are most ideal regions for the development of air masses. Atmospheric conditions should be stable for considerably long period of time, so that the air may attain the characteristics of the surface. There are 6 major source regions of the air masses on the Earth's surface. Polar oceanic areas, which comprise the North Atlantic Ocean between Canada and the Northern Europe, and North Pacific Ocean between Siberia and Canada during the winter season. Secondly, the polar and Arctic continental areas, snow-covered areas of Eurasia and Northern America, and Arctic region during the winter season. Tropical oceanic areas, which comprise the anticyclonic areas throughout the year. Tropical continental areas, which comprise North Africa, Sahara, Asia, Mississippi Valley zone of the United States, most developed in the summers. And the equatorial regions, which include the zone located between the trade winds, active throughout the year, and monsoon lands of the Southeast Asia. Classification of the air masses. Any classification of the air masses must consider the fact that all of their weather characteristics, mainly temperature, humidity and lapse rate, are properly represented and incorporated. Thus, the weather conditions of air masses at their source regions and thermodynamic and mechanical modification introduced in them during their journey away from their respective source regions must be taken into consideration while classifying them into definite categories. There are two approaches to the classification of air masses, for example, the geographical classification and the thermodynamic classification. Geographical classification. The geographical classification of air masses is based on the characteristic features of the source regions. Trevarta has classified air masses on the basis of their geographical locations into two broad categories. For example, the polar air masses which originate in the polar areas. Arctic air masses are also included in this type of category. Second, tropical air masses which originate in the tropical areas. Equatorial air masses are also included in this category. These two air masses have been further divided into two types on the basis of the nature of the surface of the source regions where continental or oceanic areas. For example, continental air masses indicated by a small letter C and the maritime air masses indicated by the small letter M. It may be pointed out that a continental air mass gets modified and is transformed into maritime type while passing through the ocean surface, but the maritime air mass is seldom transformed into continental type while passing through the land surface. Based on the above facts, air masses are classified into the following four principal types according to their geographical conditions. Continental polar air mass, which is represented by small c and capital P. Maritime polar air mass, which is represented by small m, capital P. Continental tropical air mass, represented by small c, capital T. Maritime tropical air mass, represented by small m and small t. Thermodynamic modifications and classifications of the air masses. Thermodynamic modification of an air mass involves its heating or cooling from below while passing through different surfaces away from the source region. Heating of an air mass causes decrease in the vertical stability of the atmosphere. After being originated, the air masses move out of their source region to other regions, and in the process they modify the weather conditions of the areas traveled by them, and in turn they also get modified by the surface conditions over which they move. The thermodynamic modifications of the air masses besides heating from below also include evaporation of water into the air from below or into intermediate layer by precipitation from moist air aloft. The modification of air masses depends on four factors: initial characteristics of the air mass in terms of the temperature and moisture content, nature of the land or water surface over which a particular air mass moves, path followed by the air mass from the source region to the affected area, and time taken by the air mass to reach a particular destination. An air mass, while moving over the surface whose temperature is greater than the lower layer of the moving air mass, is heated from below and becomes unstable due to the resultant steepened lapse rate and upward movement of air. This mechanism causes condensation, cloud formation and precipitation if the moving air mass contains sufficient amount of moisture content. On the other hand, if the moving air mass is warmer than the surface over which it travels, it is cooled from below, resulting into atmospheric stability, which restricts upward movement of the air, and thus there is no chance for condensation, cloud formation and precipitation. It is thus obvious that the cold polar air masses, while moving from their source regions to relatively warmer surfaces, become unstable because they are warmed from below. On the other hand, warm tropical air masses, when moved out of their source areas and reach colder surfaces, are cooled from below, causing atmospheric stability and dry weather. A warm air mass is that whose temperature is greater than the surface temperature of the region visited, while if the air mass is colder than the surface temperature, it is called the cold air mass. It is apparent that the warmness or the coldness of an air mass is determined by the temperature of the underlying surface. Air mass also undergoes thermodynamic modification when evaporation is added to it from outside. An air mass is termed stable air mass when air descends, while an air mass becomes unstable when the upward movement of the air is operative. Such mechanical modifications in an air mass are introduced due to the cyclonic and anticyclonic conditions. Besides, mechanical modifications are also introduced due to turbulent mixing caused by eddies or convection, divergence and convergence of the air masses and their effects on the lapse rate of temperature, subsidence of air and lateral expansion on the ground surface, which is the anticyclonic condition, lifting of the air and the convergence of air at the ground surface, which is the cyclonic condition, and advection. Based on the thermodynamic and the mechanical or the dynamic modifications, air masses are divided into firstly cold air mass and warm air mass, each of which is further divided into stable air mass and the unstable air mass. Cold air masses originate in the polar and the Arctic regions. They are characterized by the following properties in their source regions. Temperature is very low because of the loss of heat through outgoing long wave terrestrial radiation. Specific humidity is extremely low. Stability increases and normal lapse rate of temperature is low. Cold air masses, after moving out from their source regions and reaching other areas, have the following properties. The temperature of the areas where cold air masses reach starts decreasing. The air mass is warmed from below and thus normal lapse rate increases and the air becomes unstable. This mechanism causes convective currents. If the cold air mass lies over the warm ocean surface, then its specific humidity increases and cumulonimbus clouds are formed. The usual visibility in the air mass is maintained. Precipitation occurs only when the air mass lies over warm ocean surface, but if it lies over the warm continent, there is clear weather. If the cold air mass lies partly over the warm ocean surface and partly over the adjoining cold land surface, then the cyclonic conditions are induced. Cold air masses are further divided into continental cold air mass, maritime cold air mass. Warm air mass is that whose temperature is greater than the surface temperature of the areas over which it moves. Such air mass is cooled from below and thus its lower layer becomes stable, due to which its vertical movement stops. Warm air masses generally originate in the subtropical regions characterized by anticyclonic conditions. They are further divided into continental warm air mass and maritime warm air mass. Based on the thermodynamic and mechanical or the dynamic modifications and some other considerations, air masses are divided into 16 types as follows. Continental polar air masses, which are further divided into continental polar cold stable air mass, continental polar cold unstable air mass, continental polar warm stable air mass, continental polar warm unstable air mass, and now the maritime polar air masses are divided into maritime polar cold stable air mass, maritime polar cold unstable air mass, maritime polar warm stable air mass, maritime polar warm unstable air mass. And now The continental tropical air masses are divided into continental tropical cold stable air mass, continental tropical cold unstable air mass, continental tropical warm stable air mass, continental tropical warm unstable air mass. And now we have the maritime tropical air masses, which are further divided into maritime tropical cold stable air mass, maritime tropical cold unstable air mass, maritime tropical warm stable air mass, maritime tropical warm unstable air mass. Now that we've seen the classification of the air masses, let's move on to the front and its definition. A front may be defined as an interface or transition zone between two air masses of different density. The concept of the front was introduced in meteorology by Norwegian School of Meteorologists in about 1918. Meaning of the fronts. Front is that sloping boundary which separates two opposing air masses having contrasting characters in terms of air temperature, humidity, density, pressure and wind direction. An extensive transitional zone between two converging air masses is called the frontal zone or the frontal surface, which represents zone of discontinuity in the properties of opposing contrasting air masses. Frontal zone is neither parallel nor vertical to the ground surface, rather it is inclined at low angle. Though fronts differ from each other in terms of their location, types and aerial extent, but they are characterized by the following common characteristics. For example, large differences in the air temperature across a front, bending isobars, abrupt shift in the wind direction, cloudiness and precipitation. Creation of the fronts. When two contrasting air masses converge in deformation, circulation, they spread horizontally along the axis of outflow or dilation. In such situation, the creation of front depends on the angle between the axis of outflow and the isotherms. Fronts do not form when this angle exceeds 45 degrees. As the convergence of the air continues, this angle decreases and the isotherms try to become parallel to the axis of the outflow and frontogenesis is activated. The steepness and the intensity of the fronts depends on temperature gradient. If two contrasting air masses are parallel to each other and there is no upward displacement of the air, stationary front is formed. Such fronts climatically insignificant because they are not conducive for the cloud formation and precipitation. But such situation is not very common because two contrasting converging air masses are generally separated by a sloping boundary due to the deflective force or the Coriolis force of the earth, and the cold and dense air masses pushes warm and light air upward. It may be pointed out that the fronts are not linear between two converging contrasting air masses but are zonal in character, having a width of 5 to 80 kilometers. Classification of the fronts. Fronts are classified into four principal types on the basis of their different characteristic features: warm front, cold front, occluded front, stationary front. Warm front. Warm front is that gently sloping frontal surface along which warm and light air becomes active and aggressive and rises slowly over the cold and the dense air. The average slope of the warm fronts in the middle latitude ranges between 1:100 to 1:400. The gradually rising warm air along the gently sloping warm front is cooled adiabatically, gets saturated, and after condensation, precipitation occurs over a relatively large area for several hours in the form of moderate to gentle precipitation. Cold front. Cold front is that sloping frontal surface along which cold air becomes active and aggressive and invades the warm air territory, and being denser remains at the ground but forcibly uplifts the warm and the light air. Since the air motion is retarded at the ground surface due to the friction while the free air above has higher velocity and hence the cold front becomes much steeper than the warm front. That is why the slope of cold front varies from 1:50 to 1:100, which means the rise of the wedge of the cold air at the rate of 1 kilometer for every 50 to 100 kilometers. A cold front is associated with bad weather characterized by thick clouds, heavy downpour with thunderstorms, lightning, etc. Sometimes cold frontal precipitation is also associated with snowfall and hailstorms. Occluded front. Occluded front is formed when the cold front overtakes warm front and the warm air is completely displaced from the ground surface. Stationary front. Stationary front is formed when two contrasting air masses converge in such a way that they become parallel to each other. There is no ascent of air. In fact, the surface position of the stationary front does not move either forward or backward. Changing weather is associated with the fronts. Since fronts are formed due to convergence of two air masses of contrasting temperatures and hence contrasting weather conditions are found from north to south or south to north. Differences in terms of temperature, humidity, precipitation, cloudiness and wind direction are experienced along the different fronts, for example, warm and the cold fronts. Weather associated with the warm fronts. Warm air becomes active and aggressive along the warm front as it invades the cold air zone, and thus being lighter, it gradually rises over the cold air and is cooled adiabatically from the below. Cooling of the warm air causes condensation and cloud formation followed by precipitation. If the aggressive warm air is stable and less humid, condensation occurs at greater heights and hence much lifting of the air is required. On the other hand, if the warm air is moist and unstable, only slight lifting causes condensation and precipitation. The warm front precipitation is of long duration, moderate and widespread because of the gentle slope of the warm front. There are frequent changes in the cloud types. The sequence of the clouds from above downward comprises the cirrus, cirrostratus, altostratus and the nimbostratus. When warm front advances forward, the warm sector comes over the observation place. There is a sudden change in the weather conditions with the arrival of the warm sector. For example, a sudden increase in the temperature and specific humidity, decrease in the air pressure, disappearance of the clouds, clear sky and break in precipitation. Now, the weather associated with the cold front. Cold and dense air becomes active and aggressive along the cold front. When the cold air invades the warm air region, pushes it upward, while being denser, settles downward. If the cold front passes away soon, weather also becomes clear soon. Otherwise, if the front becomes stationary, the sky becomes overcast with cumulonimbus clouds, provided that the cold air is moist and unstable and frontal thunderstorms are formed. Heavy precipitation occurs, but it is of short duration. The consequent weather is characterized by decrease in the air temperature, increase in the air pressure, decrease in the specific and relative humidity and change in the weather direction from 45 degrees to 180 degrees. Precipitation is accompanied by lightning and cloud thunder. Sometimes rainfall is associated with hailstorms. After the passage of the cold front, clouds disappear, precipitation terminates and weather becomes clear and the northwest cold winds set in. Summary. Air mass concept was developed during the World War I by two Norwegian meteorologists, Wilhelm Bejerkenes and Jacob Bergekenes, father-son duo. This concept is also known as the air mass analysis. Air masses are three-dimensional, that is, they have vertical as well as horizontal extent. The surface separating adjacent air masses in the vertical plane is known as the frontal surface. Therefore, a frontal surface may be defined as the three-dimensional transition zone between contrasting air masses. Frontal zones are zones of discontinuities in the air mass properties.